In this video, we will learn about the general properties of transition metals. Transition metals, also called transition elements, are located at the central block between group 2 and 3 in period 4 to 7. They are all metals. They get the name transition as they are the transition of main group elements from group 2 to 3. The 10 transition metals in period 4 from scandium to zinc belong to the first transition series. Transition metals share common properties with metals in the main groups. They are malleable, ductile, shiny, and good conductors of electricity and heat. Some reactive transition metals can react with acids, water, or oxygen. In general, they are less reactive than main group metals. On the other hand, transition metals have some special properties that are different from metals in the main groups. 1. Forming colored ions in their compounds. 2. Forming more than one oxidation state in their compounds. 3. Exhibiting catalytic properties. These 3 characteristic properties of transition metals will be introduced one by one. Firstly, transition metals can form colored ions in their compounds. We have already learned some colors of ions containing transition metals in aqueous solutions. Using iron as example, iron 2 ions is pale green and iron 3 ions is yellow. Note that some aqueous ions of transition metals are colorless, like zinc ions and silver ions. Also, it is incorrect to say transition metals are colored, as we are talking about the ions. Secondly, transition metals can form more than one oxidation state in their compounds. The concept of oxidation state is the same as oxidation number. Here are some examples of transition metals exhibiting more than one oxidation state in their compounds. Remember to use the correct format to describe the oxidation number of an element, which is oxidation number of element and species is sign plus value. Using iron as example again, the oxidation number of iron in iron 2 ions is +2. That of iron in iron 3 ions is +3. Note that 2 examples are needed to show this property, and it is wrong to include the oxidation state of free element as one example. For example, the oxidation number of iron in iron metal is 0. As we are talking about oxidation state of transition metal compounds, but not of elements. Thirdly, transition metals and their compounds exhibit catalytic properties. Catalysts can increase the rate of reaction and regenerate at the end of the reaction. These 2 properties of catalysts can be illustrated by the following examples. Consider the decomposition of hydrogen peroxide into water and oxygen. This reaction is catalyzed by manganese 4 oxide, a compound of transition metal manganese. The rate of formation of oxygen gas is slow without a catalyst. However, the rate increases when manganese 4 oxide is added to hydrogen peroxide, showing that the presence of a catalyst can increase the rate of reaction. Then, consider the contact process. Oxidation of sulfur dioxide to sulfur trioxide catalyzed by vanadium 5 oxide, a compound of transition metal vanadium. This reaction helps us understand the meaning of catalyst are regenerated at the end of reaction. The catalyzed reaction involves 2 steps. First, sulfur dioxide reduces vanadium 5 oxide into vanadium 4 oxide. Then, oxygen oxidizes vanadium 4 oxide back to vanadium 5 oxide. After being consumed in the step 1, vanadium 5 oxide is regenerated in step 2. We say that vanadium 5 oxide is regenerated, which remains chemically unchanged after 2 steps. Here are some examples of transition metals or their compounds being used as catalysts. Some appear in previous chapters, like catalytic converter in chapter 20, hydrogenation in chapter 42, and decomposition of hydrogen peroxide in chapter 36. The Haber process will be introduced in Chapter 53 of the elective part, Part 13, Industrial Chemistry. The remaining two examples are for reference only. No need to remember.